Hey guys, Mr. Gucci here with the second homework help video for this assignment. In this one, I'm going to be looking at numbers 10 and number 12. Okay, now this is something that we briefly talked about in class called the dilution formula. And basically what it says is that the concentration of the starting solution times its volume is going to equal the concentration of the final solution times its volume. And remember, we measure concentration in molarity, and this formula, it makes sense. Think about if you had, you made some lemonade at home that was far, far, far too strong, meaning its concentration was too high. What would you do if you made lemonade that was too strong to drink? Well, you would add water. You would dilute it. So what happens when you dilute it? The concentration goes down because it's weaker, and the volume goes up because you put more water into it. So concentration goes down, volume goes up. That means when you multiply these two numbers together, one is lower, one is higher. The result, though, should end up being the same. So the initial moles times initial volume, the initial molarity times the initial volume equals the final molarity times the final volume. So let's try one of these problems now. Let's try number 10. Okay, here we go. So you have 1.293 liters of a 0.05 molar solution. If you dilute it to 12.035 liters, what will the new molarity be? Now watch how easy this is, guys. Now we didn't do much work in class on it, but watch this. Okay, here we go. The starting molarity times the starting volume is going to equal the final molarity times the final volume, right? The initial molarity is 0.50 molar. The initial volume is 1.293 liters, okay? Now, the final volume is 12.35 liters, so we want to know what is the final molarity, the new molarity. So, let's take a look. Well, let's do an exercise here. Let us solve this using rearranging of variables, okay? We're trying to get molarity by itself, okay? Now it's being multiplied by the second volume. So to undo multiplying by a value, we divide by that same value, all right? It'll cancel out over here, but we also have to divide it on this side. So then we're going to divide by the second volume on this side. Okay, so what this means is that the new molarity is going to be equal to the first molarity times the first volume divided by the second molarity. So here we go. All right, the first molarity is 0.05. The initial volume is 1.293 liters. All right, and we're dividing by the final volume, which is 12.035 liters. 12.035. And that's going to equal the final molarity. So I'm going to plug this in. 0.5, okay, 0.05 times 1.293 divided by 12.035. And I get, as my final molarity, 0.00537. Don't stop at 5. Don't round that 3 to a 4. Give me 3 significant figures at least, all right, to get the right answer. So that is the molarity. It is a 0.0537 molar solution. Let's plug that in and see if that's good. 0.00537 molar solution. That is correct. All right, let's try another one. Let's try another one. Okay, let's try problem number 12. Problem number 12. Here we go. Okay, so you have 275 milliliters. You have 275 milliliters of 5.136 molar solution. If you wish to dilute it to 1.733 molar, what volume must you dilute to? Now, you can use these milliliter units. You do not need to bring it to liters, all right? Because you're not actually using the molar variable in here. You're just comparing molarity. Molarity and volume. All right. So with this, you can. Okay. So listen. When you're doing like molarity equals number of moles divided by volume, it has to be in liters because that's how we tabulate molarity. But if you're using a dilution problem, all right, initial molarity times initial volume equals final molarity times final volume. Well, you could use whatever volume units you want so long as they are the same on both sides. Okay, so here we go. This one, we'll plug in numbers first and then we will solve. Okay, so you have 275 milliliters, that's the initial volume, of a 5.136 molar solution. That's the initial molarity. Okay, you wish to dilute it to 1.377 molar. That's the final molarity. So the question is, what is the final volume going to be? Well, let's plug in what we know. The initial molarity, 5.136 molar. The initial volume, 2.7, not 2.75, it's 275. 275 milliliters. That's going to equal the final molarity, which is 1.733 molar, times whatever the final volume is, which we're trying to solve for. Okay? So, again, we're trying to get volume by itself to solve for it. It's being multiplied by 1.733, so we have to divide by 1.733. And if we do it over here, it has to be done on the other side of the equation as well. So, this all cancels out. The final volume equals 5.136 times 275 divided by 1.733. Here we go. Let's try this out. 5.136 times 275 divided by 1.733. And we get 815. Okay? The answer is volume 2 equals 815 milliliters. Okay, we started with milliliter volume units at the start, and so we got to end with milliliter volume units at the end. 815 milliliters. Let's see if I got this correct. 815 milliliters. Did I screw this up somehow? Let's see here. 815. Let me double check my numbers here. 275. Let me double check this 1 second, pausing. Guess what? I did this problem correctly. Unfortunately, the built-in answer checker was wrong. The built-in answer checker did not use 275. So I'm just going to have to sneak in and fix that on everyone's forms. Hooray. I will do that now. But that's essentially it, guys. Okay, problem solved. All right, so there you go, guys. Those are your help videos for 14.2 molarity and dilution. Good luck.